Okay, so now we're on to lesson 2 of unit 6. We're working with slopes yet again, but this time a little bit more in depth because we're going to be given 2 or more lines on the graph, as you can see there. And we have to determine if they're parallel. So parallel means they never touch at all, ever. And then perpendicular means they cross, and when they cross, they create what type of angle? What does perpendicular mean? A right angle, 90-degree angle, okay? So below we have a graph consisting of 2 parallel lines and another graph consisting of 2 perpendicular lines, which means they form an angle of 90 degrees. We're going to find the slopes of each line and see what relationship exists between the two. So in this first graph here on the left, we are going to find the slopes of these parallel lines. Any guesses about what the slopes will be? Not the slope itself, but if 2 lines are parallel, what do you think this, yeah? They're going to be the same. They have the same slant. That's what slope means, right? The same steepness. So if they never touch, that means they both maintain the same steepness forever. So we're just going to quickly prove that here. So for this line on top, I would have to go up 2, 3, to the right 2, 3, 4. So I went up 3 and I went over 4. For the one down here, I would have to go up 2, 3, to the right 2, 3, 4. So Sam was right. The slopes would be absolutely identical. The slope of this first guy is 3 over 4 and the slope of the second guy is 3 over 4. So if 2 lines are parallel, they will have the same slope. Okay. Any guesses about perpendicular lines? Will the slopes be the same? No. Any guesses? Yeah. Opposite symbols. That would be a good idea. And like, look, she's right. Because this line right here is going upwards. So we know it's going to have a positive slope, right? This one's going downwards. So we know it's going to have a negative slope. That's for sure. And there's actually also something else that happens too. I'm going to show you that. So let's find the slope of this guy right here. I'll start with this line. I have to go up 1, 2, 3, 4, 5. So up 5. 1, 2, 3, 4, 5, 6, 7, 8. To the right, 8. So the slope of this guy is positive 5 over 8. Okay, now I'm going to find the slope of the other line. So I'll use these 2 dots on that other line there, and I'm going to travel down 1, 2, 3, 4, 5, 6, 7, 8. So down 8 means negative 8. Then to the right, 5, which means positive 5. So the slope of this guy is negative 8 over 5. So Tiana was right. The symbols are opposite. And what else? What else do you notice? Yes, Cole. The numbers, like it's the same numbers, 8 and 5, but we flip the fraction. One's 5 over 8, one's 8 over 5. So it's the complete opposite. We flip the fraction and we flip the symbol. Okay? So we just discovered that the slope of parallel lines are equal. And the slopes of perpendicular lines are opposite, and that takes care of the symbol part. Opposite symbols, opposite reciprocals is what we call a flipped fraction. So if I ever say reciprocal, all that means is it's the fraction reversed. The top becomes the bottom, bottom becomes the top. Okay, so opposite reciprocals. So 5, 8 became 8 over 5 with the opposite symbol. Okay. So now that we know that about parallel and perpendicular lines, we're going to do an example here. So the first example says, I have a line, we're going to call it GH, and it passes through those 2 points G and H. Then I have another line JK that passes through those points J and K. Then I have a line called MN, and that line passes through those 2 given points M and N. I want you to tell me, would those lines be parallel? How do we know? Well, the slopes would have to be equal. Now, I did not give you a big grid to draw them out. So that must mean I want you to use the formula for slope. Remember that formula we so conveniently learned in lesson 1? Just a little recap here. That formula is y2 minus y1 equals x2 minus x1. So we are going to find the slope for MN, for GH, for JK, and we're going to see if they're all equal. If there are, we know they'd be parallel. Okay, so I'm going to do the work for GH in red. So this is my x1, y1 for G and my x2, y2 for GH. And now I just plug in as per the formula. So that would be -1 minus 2 divided by 2 minus -4. So I just took what I labeled there and plugged them in as the formula said. When I simplify that, the top becomes -3 and the bottom becomes 2 plus 4 or 6. We never leave it like that. We reduce to -1/2, and there's our first slope. Now I'm going to do the same for my next set of points, and that's JK. Okay, so here are my points J and K. So that's my x1, y1, that's my x2, y2, right there. And we plug in as per the formula says. So it would be 3 minus 7 divided by 7 minus -1. Am I going too fast with that formula? Do we all get why I'm plugged? Okay. 3 minus 7 is -4 on top and on the bottom. 7 plus 1 is 8. Let's reduce that. And it reduces to -1/2. So there we go. We know that those slopes are equal. Those two will be parallel, but there's a third one it wants us to check, which I will do in green. So now I'm on M and N. So there's x1, y1, x2, y2, and I plug into the formula. So it would be 1 take away 5 divided by 5 minus -4. That would simplify to -4 over the bottom becomes 5 plus 4, which is 9. -4 over 9 cannot be reduced. So we have established that the first two are parallel, but he is not. Okay, math terminology here. This is a symbol for parallel. You can say GH is parallel to JK. MN is the odd man out. All right, not so bad. Okay, this next one is kind of similar, and this time I ask you to actually just draw them. So it says line PQ passes through those 2 points given, and line RS passes through those 2 points given. This time we're only given two lines to draw instead of 3. Then the first question asks, are they parallel? Maybe they're perpendicular, or are they neither? And it wants us to sketch them to verify. Okay? So to draw these 2 points on this graph here, I'm just going to quickly draw my X and Y axis. You could do the same. Okay. So the first set of points I'm given are PQ. I'm going to plot those. So P is -7 on the x-axis, but then 2 up on the y. So there we go. That would be my point P. Then my point Q is -2. Oh, did I draw 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, I did. There's my point Q, -2, 10. I join those. I have a line. That was a bad line. Let's try again. That was a bad line. Let's try again. Okay, whatever. All right. Next, I'm going to draw our S. So point R is found at -3 and then -4. There's R. And S is found at 5, 1. There's my 2 points. What do we think? Parallel, perpendicular, or neither? Neither. Do they cross nicely and form a 90-degree angle? Heck no. So we know they're not perpendicular. Are they parallel, or do we think they might eventually touch? Yeah, we can see that this one's in a downward motion, and eventually those two would cross based on how they're angled, right? So they're not parallel either. So then my answer for this guy is neither. Easy enough? Next page. This question right here, folks, causes a lot of trouble, okay? On the exam, I always tell kids this will be on the exam, yada, 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 make sure you study it, but then the success rate is still very low. Okay, lucky for you guys, you get to write your test open book, right? So make sure you take really good notes for this example, maybe put a big star by it. You are going to have to refer to it during your final or during your unit exam. Okay, so determine the slope of a line that is perpendicular to that line. Okay, so I am giving you 2 dots. We know 2 dots always form a line, okay? But the question is asking you, what would the perpendicular slope be to that? So first of all, we're going to find the slope of this guy. Whoops. Find the slope of that guy, and then figure out what would the perpendicular slope be. That's easy enough. Just flip it, and flip the symbols too. So let's first find the slope of EF. So again, to find the slope between 2 points, you use that formula. y2 minus y1 would be -1 minus 3 divided by x2, which is -4, subtract x1, which is 2. When you clean that up top you have -1 minus 3, which is -4, and on the bottom you have -4, take away 2 more, which is -6. You will never, ever, ever leave a fraction like that. You know better. The slope here is reduced to 2/3, and it's positive as well. 2 negatives cancel. You haven't answered my question. The question was, what would the perpendicular slope to that be? Okay, so, whoops. The perpendicular slope, we do the opposite reciprocal, so we flip the fraction and we flip the symbol. So that's the perpendicular slope to those 2 points I gave. Are you with me so far? That's the easy part. Okay, now the next part of the question says, determine the coordinates of G. What's G? We don't even have G. We have E and F, right? We have to invent a point G. So determine the coordinates of G so that the line EG is perpendicular to the line EF. Now, if we look above, we were given EF, right? We were not given G, but we were given EF. So it wants us to draw 2 lines, EF and EG, and make them perpendicular. Well, we know our starting point. We know that we can draw the line EF because we were given those points for sure. So I'm just going to draw my X and Y axis here. Okay, so like I said, it wants us to draw 2 lines, EF, EG. We don't know G, but we do know EF, so I can draw the line EF. So point E is at 2, 3. There's E, and point F is at -4, -1. So there, I've at least drawn the line EF. Now, the question says, I want to also now draw a line EG. So because it's called EG, I'm going to start at E. It's not called FG, it's called EG. So now I'm going to start at E, and I'm going to draw a line that's perpendicular to that guy. And good for us, we already found what that perpendicular slope would be. We did that at the beginning. So we start at E and we do a slope of -3, +2. So I went down 3 and to the right 2. I stop there. I connect those 2 dots. And I have just created 2 lines that form a 90-degree angle. Okay, but I haven't answered the question. What's the question? Determine the coordinates of G. So I want you to tell me that G would end up being at the point 40. Now, on the unit exam, because open book exams can be a little bit trickier because you have your notes in front of you, I might throw an extra question in here and say, is there a second option for G? What do you think? Lines go both ways, right? Lines can go in both directions, right? I chose to go down. I chose to go down 3 to the right 2 because that's my slope, right? But what can I do with that negative? I can assign it to the 2. And if that's the case, from here, from my E, I would go up 3 to the left 2, and that forms the same line. So that's another option for G. Okay? So star it, highlight it, whatever you got to do. I promise you that's on the test. Okay? We are going to skip this question today. I removed it from your homework. We're just going to do this guy and we're done. So Sam, you learned about these bad boys in like grade 5. It's a rhombus, but it's also known mathematically, more mathematically, as a parallelogram. Parallelogram kind of looks like a rectangle that was pushed over. Okay? It's barely hanging on. So I tell you in this question, do you say it's drunk? Oh, I thought you said it's drunk. That's where my mind goes. Okay. So it says A, B, C, D is a parallelogram. So parallelogram is defined as a shape with 4 sides where the opposite sides are parallel. So those 2 guys will never touch. And same with those guys, they'll never touch. Okay. Parallelograms can look like 2 things. They can look like this, the drunk rectangle, or technically, a parallelogram is also a straight up, sober rectangle. Rectangles have parallel opposite sides too. So a parallelogram can look either slanted or upright. And it can be a rectangle. So I am asking you in this question, if this is a parallelogram, is it a rectangle? Is it a sober parallelogram or a drunk parallelogram? For it to be a rectangle, what do we have to know? What do rectangles have that's special about their angles? Yeah. For that to be a rectangle, the corners have to be straight up, 90-degree angles. So all we have to do is prove that a corner is 90 degrees, and we've proved it's a rectangle. Okay, how do we prove that's 90 degrees? Huh? You have to know the sides. What does that mean? Something to do with what we've been doing this whole 25 minutes. We've been talking about perpendicular lines. What does it mean when 2 lines are perpendicular? They form a 90-degree angle. So if we can show that this line right here and this line right there are perpendicular, We know they've created a 90-degree angle. We know it's a rectangle. How do I determine if those two lines are perpendicular? I find their slopes, and they better be opposite reciprocals. Okay, so I'm going to first start with this guy right here. I'll find the slope of AB first. So I use that formula, okay? So the formula says y2 minus y1 divided by x2 minus x1. And that would be 2 over 8. 4 minus 2 is 2. 4 plus 4 on the bottom is 8. We reduce that to 1/4. So there's my slope of AB. Now I'm going to find the slope of the other side running across it. We'll call that line BD. So same deal, I'm going to find the slope. So now this is my x2, y2. This is my x1, y1.
Michael Herman, please come to the office.
So y2 would be 0 minus 4 divided by x2 would be 5 minus 4. On top, 0 minus 4 is negative 4. On the bottom, 5 minus 1 is 4. There's my two slopes. Are they perpendicular? Are they opposite reciprocals? Yeah, the fraction is flipped and the symbol is the opposite. So the big answer to this question is yes, it is a rectangle. And that's it. Okay. So your questions are listed at the bottom there, but I am removing question 13. Okay, you can cross that off. Yes.